Chapter 3, Day 2, the graph of a function. And as presented here, is a graph a function? That's what we're trying to find in the beginning. If you remember from algebra class, a function is where a graph where each possible input has exactly one corresponding output. And the vertical line test is something that we can use to actually prove if a graph is a function or not. And the way that we do that is if a vertical line intersects a graph more than once, then the graph is not a function. I hope you can read that pretty well. All right, and so if we take a look at this first example here, we have a piecewise function given to us right here. And if I were to draw vertical lines as I go through, you can see that each vertical line, even on where the split is on there, because the open circle and closed, each one hits it one time. So yes, we know that that is a function. Versus the next example, if we were to draw a vertical line, you see that it hits the graph more than once. So we know that no, this is not a function. Okay, and so there's some algebra review right there for you. Just determine if something is a function by using a vertical line test. The second part now is we're getting another function. Remember, we got one in day one. We had a bunch of graphs that we looked at. Here we're getting the semicircle parent function. If you remember, this actually comes from x squared plus y squared equals 1. And when you solve for y, this is the equation that you get. And so if we were to plug in some values to see what would work, or if you remember what a circle is, the top half of the circle, it actually would start here at -1, and it goes up here to 0, 1, and it goes to 1, 0, and it just looks like I said, half of a circle. Hopefully you drew yours a little bit better than I did. And we can see, well, the domain, as we discussed on the previous day, it is starting at a -1 with a bracket, and it's going until +1. And again, we're closing it with a bracket because we are including -1 to 1. Our range, as you can see, our lowest y value for just the top half of the circle starts at 0 included up until +1 also included. And so there we have just another graph, another function that we can add to our group that we can use for further classes that we're going to be doing. And you can see, next thing we got here, just looking at some domain and range values. Okay, remember as we discussed yesterday, the domain is all the x values in the function, and the range is all the y values. Okay, so we're doing this in for the graph that's right here. We want to find the following given information. So domain, if we start on the left-hand side and just work our way to the right, we can see that our graph begins at -4 with the closed circle. We know that we're going to include it. And there's a first break, that first piece right here, it stops at 0, not including. And then when we jump to the next piece, you can see that, all right, we're going to do a union because we are not including the 0. There nowhere is they have a closed dot on the 0. So again, we have a parenthesis to say we're going to go from 0. And if you look at the end of the graph, it looks like it technically goes on forever. So I'm going to just say until infinity. Typically, they'd give you an arrow or some kind of closing dot, something that you could see. I'm going to say it goes to infinity because of that reason that there's nothing there at the end. But later on for quiz and test, I'm sure there'll be something to help you make it more clear. Now the range, since I am suggesting that it is going down to the end there, as it kind of looks, I'm going to say the range was starting from the bottom and working our way up. We're going to say our range starts at -infinity, and it's going to go up, 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 up all the way. Even though there's the different second piece that's over there, that doesn't matter. The left-hand side, we're going to go up until the very end, and we're going to go until we get to +3. Now, if you remember, infinities always have parentheses. Since we're not including the 3, that's also going to get a parenthesis in this particular graph. Now, f of -2, remember we talked about that yesterday. We're saying if our x value is -2, what is our corresponding y value? Well, you can see that at -2, we have a corresponding y value would be -1. All right, now we're going to do the same thing. We're going to add our two answers together. So at -4, well, now we can see here at -4, right, we have a +1. plus what we just did, f of negative 2 previously, that was negative 1. So our result is 0. Okay, so by adding those two particular values together. Now, for which value x is f of x equal to 1. So if I were just to go through and I'm looking at this line right there, I want to look at when exactly is that, when does it reach that line? Well, I can see I already had that there. So at x equals negative 4. Now, the tricky thing, some of you might say, well, what about x equals 0? But remember, it's an open circle, so we're not including that. But you do see right there, we are going to reach that spot, and so we're going to put a little comma here, and we're going to say also at x equals 3. Okay, so there's the front side of it. All right, so if we go to our next page and take a look down here, we got page 2. We're going to scroll back up to the top. All right, we're taking a look here at piecewise functions. Now with piecewise functions, if you remember what we did in day 1 and then also the semicircle we got earlier today, you can use those to give you a basis for your graph to get an idea what the pattern's going to look like. If you're not quite sure where the points are going to go, you could make a small table off to the side and say, all right, I'm going to make an X, and in this case, we called it A of X. So I'm going to make that table right there. Now it says I want to go from negative 2 to negative 1. So on my table, I'm just going to put in here negative 2 and negative 1. And then I'm going to put a little bit of a break there. Okay, so I'm just going to plug these numbers in, right? If you don't remember what the graph looks like, you can plug some values in. So all right, if I take negative 2 cubed, well, that's going to be negative 8. So I know that I have negative 2, negative 8. And I got a closed circle there because it has less than or equal to. And then if I plug in negative 1, well, negative 1 cubed, and I'm plugging in this first part, negative 1 cubed is negative 1 again. So I know I'm going to have from negative 1, again, it says equal to, so I have a closed circle. Now, if you remember from yesterday, the cubic graph, so all I'm going to do is I'm going to connect this as kind of a curve, try and draw as best you can. I'm going to connect those 2 points there, okay? Now, the next part of this piecewise, that's what a piecewise function is. It's just making 2 different graphs, 2 different pictures into one, all right? And so if you look here, if you were to go through and say, okay, what I'm going to do now is I'm going to go through and look at the second piece. Now, the second piece says, well, if you start at negative 1, and we're just going to go all the values that are bigger than negative 1. So negative 1, 0, 1, 2. Now, the reason why I also did negative 1 is because you got to worry about the decimals. If you just started at 0, then you're forgetting about like negative 0.5 and negative 0.7. We need to take care of those. So what I'm going to say is, well, if I start plugging in values, I'm now going to use this part, because that's the second piece of this function. And it says, this is the condition. If x is greater than negative 1, we're going to use x squared. That's how you read that particular piecewise function notation. So if I pick a value, if I start at negative 1, I plug in negative 1 squared. Careful with the squaring of the negative. You know that's positive 1. So I know that at negative 1, I have positive 1. And because it's only greater than, we're going to say at negative 1, 1, we're going to put an open circle. And so we're going to say, okay, negative 1, 1, we have an open circle there. Now at 0, again, because it's greater than negative 1, I'm picking the x squared graph. So I'm going to say, okay, if I square it, I got 0. If I plug in 1 squared, I have 1. If I plug in 2 squared, I have a 4. And because we could keep on going, I keep going. But again, if you know the graphs we talked about yesterday, then you can continue with just the normal parabola graph, right? The quadratic that we have there. So I know that I'm going to be at 0, 0. Now these I'm going to put closed circles because this is saying going forever to the right. At 1, 1, I have right there. At 2, 4, just to give me a basic idea what the pattern is. And then I'm just going to connect it. Remember your nice quadratic curve. And this does go forever because this is saying that we're going to look at all the values greater than negative 1. So I'm going to put an arrow there. Now remember, the left-hand side was closed circles because that was not going forever, right? This one had a starting at negative 2 and a stopping at negative 1. So I only put that curve right there from the closed circle to the closed circle dot that's there. Okay, so that's how you do a piecewise function. You read the if statement, that's the conditions on the right-hand side. You start at the negative 2, you go until negative 1 using x cubed. And then once you get to greater than negative 1, again, you have to make sure you account for the decimals. Okay, so that's why when I did this is I made sure I started at negative 1 because I wanted to go through and I had to worry about all these spots, right along there. If I started at 0, I would have missed those decimals. So I got to make sure I keep that in there, okay? And that's how you graph a piecewise function. So let's try another one. All right, and it says you try. All right, if you want to pause right here and then try it on your own, go ahead, be my guest. All right, take a pause. Okay, so hopefully you got a chance to try it. So what I'm going to do here is I'm going to go through and I'm just going to start with my graph. Now it says if my condition says if x is less than 1, I'm going to use x cubed. So if I were to make a little table off to the side, and obviously the better you get at knowing these particular functions, we call them parent functions, knowing those, that will help you not to make a table. You could just plot points from the graph that you understand. So if I go here, I'm going to say x is less than 1. So you can pick a couple points, -1, 0, 1. Now in this case, I'm going to put a break right there. I know that when I get to 1, that's going to be an open circle because there is no equal sign. So if I just plug in some values, -1 is -1, 0 cubed is 0, 1 cubed is 1. That's kind of easy right there, right? So if I go here and I'm going to go through and say, okay, -1 is -1. I'm going to put a point there. I'm going to say 0, 0, and I have 1, 1. But remember now, we're not including the 1, so that's an open circle. And this is where if you want to include more points, you could do -2 to get -8, right? Things like that to help you get an idea of what the graph will look like. So I mean, if you want to include that to make a little better graph, that's fine. Or you can just remember what the parent function looks like, and that's a nice cubic graph that's going to go down forever. Because again, we're saying all the values that are less than 1, we're going to use x cubed. Okay? Now, we get to the next thing. We go from left to right. We say, oh, well, you know what? We did all the values until we got to 1. Now we say, what happens when we get bigger than 1? So I'm going to put on my graph here, 1, 2. And I could do 2, but if you look at your graph that we're going to look at square root. And if you want to graph the square root of 2, now I know it's 1.4. You may not know that. So what you might want to do instead is pick a number that's a perfect square. So hopefully when you do this, try this on your own, maybe you pick like 4. And then maybe you pick like 9 so that when you make this graph, you got numbers that are nice and easy to plot. So when I say, okay, well, the square root of 1 we know is 1. Now again, it's going to be an open circle because it's not equal to. So I'm going to say 1, 1, and I can just or trace that if I want to, but I cannot fill it in. Okay, that's the big thing that you have to understand. You're not going to fill that part in. Now, when I take 4 and I plug it in, because that's bigger than 1, take the square root of 4, and obviously that's just 2. If I take the square root of 9, I'm going to get 3. So I know that 4 is 2, and I know that 9 is 3. And all I'm going to do is, remember we talked about the square root graph yesterday, but I'm only looking at the portion that's from bigger than 1. So I'm just going to look at starting at 1 and going forever to the right, because that's what I'm going to say is I want this graph to go here forever to the right. It goes up at a slow, easy pace as we discussed yesterday. And so that's just my quadratic, I'm sorry, my square root graph that I have that's going to go forever to the right. So my purple, you can see, is my cubic. Everything that is less than 1, I have this cubic graph that you can see that's on the left-hand side. If I look at everything greater than 1, I have this square root graph that I have in blue that I can look at and I can go through and I can say that piece. But both of these, this is what's called a piecewise function. Both of these together make up the entire function. And we talked about passing the vertical line test. I could draw vertical lines. You don't have to, but I could draw vertical lines and I could see that, yes, it would pass the vertical line test because each vertical line would only hit it one time. Okay, so there's some graphing of some piecewise functions that we can see. All right, so if we take a look at the third page, all right, one more page here, identifying values on a graph. Okay, so if we go here, go back to my purple, this is the graph you can see on the right-hand side. It's saying, is f of 0 positive or negative? Well, you look at, now if you remember, this is f of x. That means that inside here is your x value. So when x is 0, we're looking at this portion right there. We can say, obviously, that's above the x-axis. So we know that this would be a positive value that we can see there. Okay? So if we look at f of -2, Well, if I go when x is -2, so if I go back, I'm asking for the y value. So when I go to x is -2, if I count up 1, 2, 3, 4, I know that f of -2 would be 4. Now, if I look at f of 2, so I go when x is 2, I count up to f of x, so I count up 1, 2, so I know that f of 2 is 2. Again, I'm looking for the y values. When x is 1, I go up, and it's nice, it's also going to be 1 for my y value. Now, when I go to when x is 3, I go out to here, and I can see that my y value is 0. All right. So I want to know which is larger, f of 2 or f of 4. You can either get it from the graph by looking at the placement, or you can actually just write down, you say, well, f of 2 we talked about already from previously. We know that that is 2. And we want to know f of 4. Well, now we go out to 4. If we count down, well, that's -2. Well, obviously, we know that 2 is greater than -2, so we know that f of 2 has to be greater than f of 4. Okay, and you can also see it from the graph. You can see this up here is obviously much higher of a value than that one at the bottom there. All right, so now we have f of 4. We can use that idea right here and say, well, we just talked about that being -2. We said that f of 1, we know that that is 1. So if we were to take -2 and subtract 1 more, we're going to get a total of -3. Now, the second part just simply, or letter E, just says, well, now take the absolute value of that answer. So no point in redoing everything. Let's just use that and say, if I want to take the absolute value of -3, right? What's the distance between those two particular y values? We would say, because that's the whole idea of the absolute value, we know that it's a +3. So you'd say the distance between f of 4 and f of 1 is 3 units. All right, so now going back to our graph here. Oops, sorry about that. Okay, so if we want to go here, we take a look at our domain. Well, our domain, as we can see from our graph, we're going to start at -2. Oops, gotta go there, -2. And that's going to be a bracket because we're including it. And the furthest that we're going to go, as we already discussed, is +4. So there we go. We have our from -2 to +4. And then if we look at our range, well, again, we're starting at the lowest point of our range. Okay, so we're going to start at the lowest point of our range here that we can see. Our lowest value for the range is -2, which is a bracket because we're including -2. As we go all the way, work our way up, we can see that we reach a height of 4. All right, and so it just happens in this case, the domain and range is the same. That does not always happen. Doesn't matter about this curves and how this little breaks, little jumps in there. All we know is that it's starting at -2 is our lowest y value, and we work our way all the way until we get to +4. Okay. All right, so now you have a U try. This is an interesting U try that we have there. And the way that you read this is that each of these lines here that you can see here is going to be a straight line, and not mean just a straight line, but a straight vertical line, right? As you can kind of go here, or you can see that it's going to be a straight horizontal line. And that makes a big difference. You're trying to find these different coordinates, okay? So since we're given the square root of 2 to start here, I'm going to get rid of these other lines right there for a second, okay? So since we're given the square root of 2 to start, I'm going to use that because you're going straight vertical. We know that we can find the p-value first, or the coordinates. We can say that P has to have the same exact x coordinate because that vertical line here. So we know that its x coordinate is the square root of 2. Now the question becomes, well, what's the y coordinate? Well, if you look at it, it's on the f of x graph. So what we can do then, as we discussed yesterday, is we can take that square root of 2 and we can plug it into that function. And we can go through and say, okay, well, that means that we're going to have the square root of 2 cubed minus 3 times the square root of 2. And that's going to give us our coordinates that we have there. And so when we solve this, we get the square root of 2. Now be careful. Remember, square root of 2 cubed, you're looking at doing square root of 2 times square root of 2 times square root of 2. Or you're saying this is going to be 2 radical 2. Then you got to subtract that. So I have -1 radical 2. If you want to go through and putting then the 1 actually in there, that's fine, but that's not required. So now we have our coordinates for P. And what we can do the next part is we got to go find Q. Well, if you follow this horizontal line, that's the idea, and recognizing that. If you follow the horizontal line, hopefully you recognize that they have the same Y values. So we know that the Y value has to be negative square root of 2. And since the Q is on the line y equals x, that means if the y value is negative root 2, that means the x value has to be the same thing. So easily, we got the q value. All right, now we got a little bit of a trickier one. So now we got to go through and get the r. We'll use a little green here. Now, if you notice here, q and r are on the same vertical line. So we know that r is going to have the exact same x value that q had, right? We can just use it right there. Okay, similarly as we did this, and we were able to go through and use this as the y value. All right, so now we're trying to get this. We have the x coordinate, and we see that it's on this curve here. We see this, again, we're going to use the f of x equation. Okay, so we can go through and say, all right, well, we want to find the y value. We're going to take, using some great notation, we're going to plug in the negative square root of 2 into this function, right, using great notation that we have there. Now, looking at it carefully, right, and being very, very careful that we have here, we know that the x coordinate, as we already said, is negative square root of 2. If you need to off to the side, write it out, whatever the case is. If you solve it carefully with the cube and the combining like terms and the negative in there, please be careful. You should get a positive square root of 2. And that is going to be the coordinates of the r. And you kind of see, right, the y value is positive. And if you look, yeah, the y value is positive. It's above the x-axis. If you go back, we should talk about this earlier, but if you go back, we got a negative radical 2. Well, look, P is located below the x-axis. So there you go. You can kind of, as a quick check to see that everything matches up. All right, well, there's day 2. Hope everything went well. If you got any questions, please make sure to ask, and good luck with the homework tonight.